Hello dear students, in this class we will start refraction of light. In the previous classes we have already covered reflection. So what is refraction? So with this diagram we will try to understand the meaning of refraction. So here what happens whenever light moves from one transparent medium to another transparent medium having different optical density, it bends. For example, here, suppose this is a bucket of water. Okay. This is air above here. This one is air above the bucket of water. Here, when light ray incident on the surface of water, rather than moving on the same path, what will happen here? The ray of light bends. Okay, the ray of light, it doesn't move in the same path, it bends. Okay, so this bending of light from one medium, in this case that is air medium, to other medium, that is water medium, it is called refraction. So with the help of this diagram, we try to understand when light travels obliquely or when traveling obliquely from one medium to another, the direction of propagation of light in the second medium changes. So here in this glass, if you see, this is the layer of water, this one. Above this layer of water, air is present. Okay, here this is air. Here this one is water. So this is a pencil. Now here what happens when the pencil is inserted inside the glass of water. Now you can see the pencil doesn't look like a straight pencil. It seems that the pencil is curved one. At this point, at the surface of the water, it started bending towards the downward direction. Okay, it started bending. So here what happens, the pencil is not actually bent. It is a straight pencil. But as the medium changes from air medium to water medium, and two different medium having two different density, the light ray bends. It doesn't move in the straight line. Okay, so this phenomenon of light is known as refraction. But if the angle is 90 degree, here you can see the difference between these two diagram. Here you can see here, that's at the point, in this point, the pencil doesn't look like a continuous pencil. It looks like that it is being broken. It is broken. But here it looks like a continuous one. So here what happens when the light ray is normal. Normal means perpendicular. When the light ray is normal to the surface, to the surface of the medium, then here the laws of refraction does not work. That means here this ray comes in a straight line and it does not get bends towards any other direction. Okay, but when it is oblique, here it bends towards the normal or away from the normal. Here it is written that when traveling obliquely, this point you should keep in mind. Laws of refraction will hold good if and only if there is some angle between the ray of light, that is incident ray, and the surface of the medium. Okay, so just you remember that refraction is a phenomenon of light where the light change its propagation or change its direction when it moves from one medium to another medium. Okay, now you can see here refraction through a rectangular glass slab. This is a glass slab. Glass slab means a rectangular piece of glass. Okay, so like this one, as I am doing this diagram here. So this is a rectangular piece of glass. Okay, like this. This is a rectangular piece of glass. Okay, so here we are considering this surface, this one. Here what I am shading here, this surface we are considering. Okay, this one. So this is A, B, D, C. Same here, this upper one is A, this one is B, this one is D, and this one is C. Here what happens, suppose EF is the incident ray of light which falls on this surface. So this is the line EF. EF is the incident ray that falls on the surface. So this is the surface. Okay. Now from where the ray of light is coming? From air medium. Okay. Now this is glass medium, this is air, this is glass, both are different medium. So what happens, suppose at this is the point where the incident occur, or this is the points of incident. So if you draw a perpendicular here, this becomes the normal. Okay. Now this becomes the angle of incident, that is I or I1 here. So if you draw a normal here, a normal, so this becomes angle of incident. Now, after getting incidented, here as because glass is also a transparent medium, the light should pass through the glass. But how the light will pass? The light will not pass through the same path, this path. As because the density of the medium are different, it bends towards the normal. So this is normal, it is bending towards the normal. Okay. So here one thing you should keep in mind, that if the incident ray is coming from rarer medium to denser medium. Rarer medium means the medium which is having low density. Denser medium means the medium which is having high density. Okay. So if the ray of light is coming from rarer medium to denser medium, then the refracted ray. So this is incident ray of light EF. This one is refracted ray of light. Okay. So this refracted ray of light will bend towards the normal. That means it will bend in this direction. In this direction. See, earlier this was the direction, now it it is little bit close towards the normal. Now this is the incident ray, this is the refracted ray. Okay. Now this is the angle of refraction R1, where in this case R1 is less than I1. Okay, here R1 is less than I1. Okay, so here this refracted ray, angle of refraction is less than angle of incident. Now for this point O dash, for this point on this line CD, for this point O dash, here O dash this ray behaves as an angle of incident for this point O. Now here this is the denser medium, glass medium, this is the rarer medium, that is air medium. Now from denser medium to rarer medium, the ray of light is coming out, it is emerging out. Okay. So here what happens, in the first case, as the incident ray was coming from rarer to denser medium, the refracted ray is getting close to the normal. But here the case is different, it is opposite. Here in this case, the incident ray is coming from rarer medium and it is moving out to denser medium. That is why the refracted ray for this medium is moving away from the normal. That means if I draw a straight line here, it should move in this direction. But rather moving in this direction, it will move away from the normal. This is the normal. It will move away from the normal. Okay. So here GH, here this ray is known as emergent ray. Now the original direction of the incident ray, that is the dotted line, and the ray which is finally coming out of the glass slab, these two are parallel to each other. These two lines are parallel to each other. Okay. Okay. So this is all about refraction through a rectangular glass slab. So here what happens, this is a glass slab. Okay. When the ray of light incident on it, rather than moving on the straight line, it bends towards the normal, that it changes its angle. Then when it is coming out, rather than moving on the same straight line, it moves away from it. Okay. And these two lines, that is the imaginary line and this is the real line, these two are parallel to each other. Okay. Now here we saw what is refraction and how it takes place on a glass slab. Now, what is the cause of refraction? Refraction is due to change in the speed of light as it enters from one transparent medium to another. So here what we saw that in the previous slide, that's in this glass slab, here this is air, this region is air, this one is glass, this region is air. So there are this glass slab is covered by two air, two layers of air. So when light enters, the density of air medium is different compared to the density of the glass slab. So in this case what happens, the speed of the light, that is the velocity of the light, changes. As the velocity of light changes, it bends, it cannot move along the same path. Like suppose this is a road, okay, this is a road. Now suppose a bike is given to you and you are being asked to ride the bike with full speed. In the road, if no one is there, if the road is completely empty, then you can easily ride your bike with whatever you speed you want. Now suppose the road is being crowded, there are lots of people here. Can you ride your bike freely? No, you have to ride your bike slowly, otherwise accident might happen. Same thing happens here. As in case of low density medium, that is rarer medium, the light moves through its full speed. But when the density increases, the speed decreases. Due to the decrease of velocity, the path of the ray of light changes. It bends towards the normal, that is the region. Now, refraction of light occurs according to certain law. Now, this refraction, what is refraction we just saw? Refraction is nothing but the bending of light when there is a difference in the density of the medium. Now, there are certain laws through which it bends. First one, that the incident ray, the refracted ray, and the normal to the interface of two transparent medium at the point of incident all lie on the same plane. That means suppose this is a plane, this is rarer medium, this region is rarer medium, this one is denser medium. Suppose this is air, this is water. Now here this is the incident ray. At this point I can draw a normal. So what it is telling, that this is the refracted ray. Okay, the incident ray, the normal, and the refracted ray all will lie on the same plane. So this law is similar to the first law of reflection. Okay, now the second point. The second point is very important, that is the ratio of sine of angle of incident to the sine of angle of refraction is a constant for the light of a given color and for the given pair of media. That means suppose this is a plane. Above this plane the rarer medium is there, here the denser medium is there, this is the incident ray of light. Now this is the refracted ray. Okay, so if we draw a normal here, this is the angle of incident, this is the angle of refraction. Okay, now here sine of this angle, suppose if this angle is I, then sine of this angle here, sine of incident angle, suppose this angle is R, this angle is R, then sine of refracted angle, if you take these two value, its ratio, it will always be a constant. That is the second law. Okay, now this holds good for any given color of light, for a given color and for a given pair of medium. Okay, this law is known as Snell's law of refraction. The name you should remember. This law is also known as Snell's law. This is true for angle 0 to 90 degrees. So this law holds good if this angle is more than 0 degree and less than 90 degree. If I is the angle of incident and R is the angle of refraction, then sin I by sin R equal to constant. Okay, now this is the star, that means you should keep this one in mind. This constant value is called a refractive index. This is very important, this term, refractive index. The constant value that you are getting by taking the ratio of sine of incident angle 2, that of sine of refracted angle is constant. That constant is known as refractive index. Refractive index of what? Of the second medium with respect to the first medium. So this constant is, this is the first medium, this is the second medium. The medium is, which one is first and which one is second medium, that is decided according to the ray of light. So this light is coming from rarer to denser. That is why it is first medium, this is second medium. Now this constant is known as refractive medium. From second medium, refractive index of the second medium with respect to the first medium. See, refractive index of first medium with respect to second is different. Refractive index of second with respect to first is different. So when I am saying that refractive index of second with respect to first, that means light is coming from first to second. If I say refractive index of first with respect to second, that means light is moving from second to first. Okay. Now here is our term, the refractive index. A ray of light that travels obliquely. Here you should keep this one in mind. It should travel obliquely, not perpendicularly or parallelly. From one transparent medium into another will change its direction in the second medium. That means whenever a light is traveling from one transparent medium to another transparent medium, it will not go to its original path. It will deviate from its path. Okay, it will be deviated, or it will deviate its path. The extent of the change in direction that takes place in a given pair of medium may be expressed in terms of refractive index, the constant. That means how much the angle is going to be changed. Now see, this is the angle of incident. Okay, this angle and this angle, this total angle, both are same. But in this case, the angle of refraction is less than angle of incident. By how much it is going to be changed, that can be known by using the Snell's law, by using the constant. Okay, that is refractive index of second medium with respect to first medium in this case. The refractive index can be linked to an important physical quantity, the relative speed of propagation of light in different media. It turns out that light propagates with different speed in different media. As we saw here, that why does the bending of light takes place when light travels from one medium to another medium? So this is due to the difference in density between two medium. So 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 from rarer to denser medium, as the density changes, if I say, if I increase or decrease the density of the denser medium, as because the ray of light, the direction of ray of light depends on the density of the medium. If the density of the medium increases or decreases, so accordingly the direction of propagation of refracted ray will also increase or decrease. Suppose here, for certain value, for this denser medium, suppose its density is x. So if density is x, the refracted ray will travel in this direction. Now suppose the density of this medium will change to x plus 1 or x plus 2. Accordingly, the refracted angle will also change. Okay, that so for what value of the density, how much angle will change, that can be known with the help of the physical quantity, that is refractive index. So refractive index, what is refractive index? It is nothing but the comparison of the sine of angle I to the sine of angle R, which is a constant. Now the sine of angle R depends on the density of the medium. Okay, because sine of angle I, it can be any angle, but the sine of angle R for a particular value of incident angle and for a particular density, the sine of R depends on the both of the factor. So if the density changes, R value, the sine of angle R value will also change. So for a particular angle, what, and for a particular density, what will be its refractive index, and with how much speed the uh, speed of the light will travel in denser medium, that can be calculated. Okay, so here it might be little bit difficult for you to understand, but once we solve one or two problems, you can easily understand it. It's very easy though. Okay. Now, the value of refractive index for a given pair of media depends upon the speed of the light of the two medium, as I told you. So the refractive index, what will be the refractive index? It depends upon speed of the light. Okay, refractive index depends upon speed of the light. And for what factor speed of the light depends upon? The speed of the light depends upon the density of the medium. So if the density of the medium changes, speed of light will change. If speed of light will change, then the angle of refraction will change. If angle of refraction will change, then the ratio of sine of angle I and sine of angle R will change. If these two values change, then refractive index will also change. Is not it? Okay. So the refractive index of medium 2 with respect to medium 1. So as I told you, if it is written medium 2 with respect to medium 1, that means light is moving from medium 1 to medium 2, is given by the ratio of speed of light of medium 1 and speed of light in medium 2. So as we saw that the refractive index can be written as sine of angle I divided by sine of angle R. It can also be written as what is the speed of light in medium 1 divided by what is the speed of light in medium 2. So the refractive index can be represented with this symbol. Okay. Okay, n to 1. That means refractive index of the medium 2 with respect to the medium 1. So that is where V1 is the speed of light in first medium, V2 is the speed of light in second medium. So you can calculate the refractive index with the help of the ratio of sine of angle I to the sine of angle R, or it can also be calculated by taking the speed of light in first medium to the speed of light in second medium. Okay. Now the refractive index of medium 1 with respect to medium 2. What we saw earlier? Earlier we saw that refractive index of medium 2 with respect to medium 1. Here we are seeing refractive index of medium 1 with respect to medium 2, just is opposite. Here earlier it was 2, it was 1, now it changes. So when this changes, this will also change. Earlier it was 2 1. 2 with respect to 1. Now it is 1 with respect to 2. So this also changes. The speed of light in medium 2 divided by speed of light in medium 1. Earlier it was speed of light in medium 1 divided by speed of light in medium 2. Now it changes. So here velocity is also changes. That means speed of light in medium 2 divided by medium 1. So it is just the reciprocal of each other. Okay. Now there are some special cases that if medium 1 is vacuum or air, then the refractive index of medium 2 is considered with respect to vacuum. This is called absolute refractive index of the medium. So this is a very important short question. What is absolute refractive index? Many a time this question has been asked in the board exam. So here what happens, as we are talking about two medium, one is rarer medium and another one is denser medium. So if this rarer medium is either air or vacuum, then in this case the refractive index is known as absolute refractive index. This medium can be different. Suppose this is water, this is glass slab. Okay, now this is glass slab, this is something else. But if the rarer medium is either glass or vacuum, and denser medium whatever it may be, but it has to be transparent medium. Okay, otherwise light will not refract, it will be reflected. So if rarer medium is either air or vacuum, then in this case the refractive index is known as absolute refractive index. Now if c is the speed of light, what is the speed of light? We know what is the speed of light? 3 into 10 to the power 8 meter per second. That is 3 lakh kilometer per second. So if c is the speed of light in air and v is the speed of light in the medium. So here then the refractive index of the medium is given by speed of light in air. So here this is air and this one is certain medium. So here if c is the speed of light and here v is the speed of light. So what will be the refractive index of this denser medium with respect to the rarer medium? C divided by V, that is speed of the light in the rarer medium to speed of light in the denser medium, that is C divided by V. Okay, the absolute refractive index of a medium is simply called its refractive index. Okay, so for that particular medium, in this case if you consider this particular case, then this is also known as refractive index of that particular medium. Okay. Now there are certain refractive index with respect to the material are given, although this is not required to remember, but still you can go through this. Okay. There are some notes. An optically denser medium may not possess greater mass density. For example, kerosene having higher refractive index is optically denser than water, although its mass density is less than water. So here what it is trying to tell you, that here we are talking about density of rarer medium and denser medium. So here we are taking density not as mass per unit volume. We are taking optical density. Optical density, what is optical density? Optical density is per one unit time, per one unit volume, how much intensity of light can pass through it. Okay, so this might be a little bit difficult for you, these words. So in the higher classes you are going to read about optical density, but for now you just remember that optical density and density both are not same, both are different. Okay, optical density means for a particular medium in 1 second how much light can pass through it. That is called optical density. Okay, it is different from normal density. Now, there are certain miscellaneous points. The ability of a medium to reflect light is also expressed in terms of optical density. That, see, you can see there are different medium of which some medium can absorb more light, some medium can reflect more light, some medium can refract more light. So it depends upon its optical density. Optical density has a definite connotation. It is not the same as mass density. As I told you, mass density and optical density both are completely different concepts. We have been using the terms rarer medium and denser medium in this chapter. It's actually means optically rarer medium and optically denser medium respectively. So earlier in the previous slides we used the word rarer medium, denser medium. That is not actually depends upon its density, it depends upon its optical density. Okay, now when we say that a medium is optically denser than the other, in comparison to media, the one with the larger refractive index is optically denser medium than the other. And how will you conclude that which one is optically denser and which one is optically rarer? So the medium having large refractive index is considered as optically denser medium. The medium having low refractive index comparatively, that is considered as optically rarer medium. This the other media of low refractive index is optically rarer. So the speed of the light is higher in the rarer medium than denser medium. So here speed of the light is inversely proportional to the refractive index. Okay. So if refractive index is more, speed of light is less. If refractive index is less, speed of light will more. Okay. The speed of light is higher in a rarer medium than a denser medium. Thus, a ray of light traveling from a rarer medium to a denser medium slows down and bends towards the normal, as I explained you. When it travels from a denser medium to a rarer medium, it speeds up and bends away from the normal. Okay. So, so here I end the class here. In the coming video, we'll be talking about these questions, and this class was based on total theory. So you must have lots of doubts in the class. So watch the video again, and when we will be solving these questions, your doubts will be automatically cleared. Okay, thank you and have a nice day.